Sweet. Thanks, Peter. Hey, everyone. Hope you're having a good Thursday. So today I'm going to be presenting a paper which is called RAFT, stands for Retrieval Augmented Fine-Tuning. I think the main contribution or innovation of this paper is a different way to approach fine-tuning an LLM for the purpose of doing question answering on domain-specific data, so data that's not necessarily like common knowledge, and to improve the capabilities for models to like retrieve information in context by doing like a very specific type of fine-tuning that they've experimented with here. So as Peter mentioned, please do feel free to like interrupt me as I'm talking through the paper. The paper itself is quite short and quite straightforward. So there's probably going to be like lots of chances for discussions and questions as we go through it. So yeah, please do jump in. Cool. So as I mentioned, in the current world, let's say you're in a context where you have a specific type of data, like a domain-specific data. They give some examples of like that could be like a code base that you're working with, or it could be a set of like regulations or type of documentation. It could be like medical research papers or whatever. So let's say you have this kind of domain-specific data. The problem that we're addressing is like, how do you get an LLM to reason and answer questions about that data in the most accurate way possible? Currently, there's two approaches to this, which those of you familiar with LLMs will probably have come across. The first is, or one of them is, you can do retrieval augmented generation. So use an existing out-of-the-box LLM, and in the context of the LLM, feed in snippets and context from your documents or your data, and then ask a question. And so the idea being that the language model will be able to reason about what's in its context window and then be able to answer the question. So that's retrieval augmented generation, really popular right now. I feel like most LLM products I see out there are like retrieval augmented generation. And then there's fine-tuning. So fine-tuning is different in that like you start with a language model and you create a data set of like samples where you are trying to bake in the knowledge of your like domain-specific data into the model by doing fine-tuning. So those are the current two approaches. But what they do here is they say, well, we can probably leverage both in some way and do like a middle ground. And so that's what they call retrieval augmented fine-tuning. So what that is like, it's effectively, it is fine-tuning, but on a slightly modified data set and slightly different way of doing fine-tuning. So what they do is they fine-tune a model to not only be able to answer questions given the context that it's given some documents, but they also train the model to try to spot like what is the important document within the context, or what things should it pay attention to and what things should it ignore. So we'll go into like the details of it as I go through the paper. But what they show is that this type of fine-tuning can really improve the accuracy of responses on domain-specific data. Cool. So the first part is like very introductory, kind of covers the things I've mentioned. They go through like the advantages and disadvantages of doing RAG and fine-tuning. So obviously with RAG, the disadvantage is that the model hasn't been trained on, potentially hasn't been trained on that data. So you're relying on the fact that it can reason over a context to be able to answer a question. Yeah, without it ever having seen that data. And supervised fine tuning does offer the opportunity to sort of learn over that data. But most, what they say here is that most times you do fine tuning, you don't then do RAG, although there's no reason you can't also do fine tuning and RAG. And in fact, they use that as one of their baselines. I quite like the analogy that they use to exams. So this is their kind of diagram. So they say like supervised fine tuning is like a closed book exam in that you are given, let's say we're focusing on like the medical field. So you're given like a set of papers and documents about the medical field. You're supposed to study them, and then at the exam time, which is test time, you don't have access to those documents. You're supposed to sort of memorize what you see. Open book exam, on the other hand, is let's say you've never studied medicine before. You go into an exam, but you're given all of this, like all of these supporting documents to say you can use these to be able to answer the question. So that's the equivalent of like retrieval augmented generation. And what they say is like, surely it's actually better to study for an exam and also have the supporting documents in the exam. So that's what they say is like the retrieval augmented fine tuning. There's kind of a neat analogy for that. So more like formally, what they say is like where they're training, they are doing fine tuning on a data set which involves a question, a set of documents, and then like an answer, where the answer that they fine tune on is includes chain of thought, so includes some reasoning, and they show that that actually helps improve the accuracy of the final model. But importantly, they also introduce distractor documents within the data set for training. And the reason they do that is they want to, I suppose, make the model robust to having documents that are completely irrelevant to the question in the context. And I think this is like a really important thing to train, because the reality is I think most retrieval augmented generation applications out there, you're never going to have the perfect context in the perfect set of documents in the context. The likelihood is you'll have some that are relevant and some that are totally irrelevant. And so it's powerful to have the model be able to reason over what's important, what's not important when it's answering the question. Yeah, so this is the analogy, the open book exams. And in terms of data sets, they chose a couple of data sets to use to showcase how it performs on like data sets that are more common knowledge, i.e. Wikipedia, and data sets that are much more domain specific. But we'll go through those in a sec. So yeah, as I mentioned, the actual methodology of retrieval augmented fine tuning is not particularly like complicated. What they're doing is they have a data set which consists of a query, an oracle document, they call it. So that's the document that contains the answer to the query or important information for it. They have some like negative documents, which they call distractor documents. And then they'll have the answer. And the answer will be like a reasoning with an extracted quote from the oracle document and then the answer. So the main difference to supervised fine tuning is the fact that they include the documents at training time as well. So it's not just like a set of question answer pairs. It's like question plus context and answer. I think one implementation detail I wanted to point out here is that, which I found this super interesting, is that the way they prepare the data set, they have this hyperparameter P, which says like what proportion of questions in the data set actually have the important Oracle document in the context. So they, on purpose, create some samples in the training data. Well, they have a question. Let's say the question is like, what Hugging Face API do I need to use to translate English to Chinese or something? And they'll introduce a set of documents, but none of those documents will actually contain the answer. And the reason that they do this, or the reason they include these, like, I'll call them bad examples, is that they're trying to make the model, well, A, memorize some of the answers, so actually learn the relationships between questions, answers without relying on the context. But I think also, I imagine like a side effect or a good bonus of that is that the models become robust to noise in the context. So like they learn to just ignore it if it really isn't relevant. Whereas I imagine if you tried, I haven't tried this, but if you tried with LLM to introduce like a bunch of context and ask a question about it, that it might cause some hallucinations because of what's in the context potentially, depending on the size of the model, I guess. So I thought that was quite an interesting part. And they go into later in the paper about like what fraction seems to work well. So in sorry, excuse me. So yeah, in terms of the data sets that are used, they sort of split them into 3 different types of data sets. So the first is data sets that cover like common knowledge, natural questions, trivia QA, and hotpot QA. I think hotpot QA is like an interesting one because it relies on doing like multi-hop reasoning. So, for example, is like, who is married, or who is the spouse of the person that directed this movie? First, you need to know who directed that movie, and then you need to find like who the spouse is of that person. That's just like a probably a bad example, but like you need to do multi-steps to answer the question. So hotpot QA is quite a popular benchmark for retrieval because of that. Then the second set of data sets they have are the Hugging Face, Torch Hub, and TensorFlow Hub API documentation. I didn't realize this until like just this morning, but the people who wrote this paper also created Gorilla, which is like the LLM that is fine-tuned to work with different types of APIs. So that's why they like Hugging Face, Torch Hub, and TensorFlow Hub, because that's what Gorilla is like trained to work with. The idea being that like you can ask it questions to do something, and it can at a much higher accuracy like interact with those APIs or use those APIs. And the third is like a different type of domain data set. So they look at PubMed QA for biomedical research. Yeah, just that. So yeah, one sort of general domain, and the other 2 are like domain specific, in that there's like API documentation and biomedical research questions. And so they compare their approach to 4 different baselines. The first is like Llama 2 with no fine tuning, no RAG, just like out of the box, can it answer these questions? as you can imagine, the answer is probably not in a lot of cases. Second is just out of the box Llama 2 with RAG. The third is doing fine tuning, but then not providing the documents at test time. And the fourth is fine tuning with also retrieval augmented generation. So they do have like the documents in the context at training at test time. Cool. So given that, let's look at the results. So what they show is generally their method outperforms all of the baselines. It matches it. In some cases, it really outperforms, and in others, it outperforms only a little bit. So for example, for hop-pot QA, which is the one I mentioned, the multi-hop reasoning, it does much better than like any of the baselines, which is kind of interesting. But also GPT 3.5 with retrieval augmented generation outperforms it on that one. So don't know how to feel about that. But I guess what they're showing here is that like their method of fine-tuning Llama 2 works much better for that type of question answering when there's maybe more reasoning you need to do over your context. It also seems to do better with PubMed, or like almost on par with fine-tuning plus RAG. And then, yeah, Hugging Face, it really it also is like quite a significant leap in accuracy. I don't know if that's because Hugging Face documentation is like expansive and hard to get started with, or what it says about Hugging Face documentation.
Maybe the code that they write looks very similar for a lot of different use cases, so it's hard to use RAG by itself.
Yeah, that could be. So yeah, generally they show like across the board for all these different data sets, it's like as good, if not better than the different baselines. Is RAM 2 really so bad on domain specific benchmarks? Well, I suppose the Hugging Face, I don't know, it depends on the data set cutoff and like how much the APIs have changed maybe. Like with Hugging Face, Torch, and TensorFlow. It's a good question. I don't know. Yeah, Bahan.
Isn't it funny that on some tasks, Llama 2 just gets 0? How do they measure that?
Yeah, that's kind of a criticism of the paper I had, which is like they don't really explain the evaluation. They just say it achieves X%. It's like X% of what? And
is this one of those metrics when they do what was the other paper that we looked at emergent abilities? Right, they measure with a cutoff. So even though the model isn't too bad, it gets 0 because it doesn't give the right answer specifically.
Yeah.
So depending on the metrics you use, right? And then maybe kind of nudge it a little bit, and then it suddenly becomes so much better.
So those 3 data sets, they are data sets where you're answering questions about what code, like you want to do something with Hugging Face or Torch or TensorFlow, but you don't know what code to use. So the answer is code. So either you can run that code, or maybe they're just saying like, we're expecting this exact answer, something like that, maybe. But
yeah, I guess
for those data sets, you could just like try running the code that it's outputting.
It's like if you miss one indent, and then your Python code just won't run, and then you get 0.
Could be.
I can see that happening.
Yeah, I haven't looked at the data sets so much, but I wonder if it's like writing I wonder if the questions are like the answers are multi-line complex answers, or whether it's just like one API call or interface or something.
I'm not sure. I guess we probably have to refer to the Gorilla paper to figure it out.
Yeah, probably. But yeah, it's interesting. It's like I've looked at this table quite a bit, and the differences in performance I find quite weird and hard to justify. Like, for example, with Hugging Face, doing fine tuning gets it to 61%, but then doing RAG with it suddenly brings it down to like almost 20%. It's like, how are you doing RAG that makes it that much worse also?
That's a good spot. Another question is like, where are the error bars? Like, or are they just using greedy decoding so you get the same answer every time?
Yeah. Yeah, the paper is lacking, I think, I think it's a cool method and they explain the method well, but it's lacking in some detail, I think, in the evaluation and the sort of the setup for it.
I guess it's the trade-off between doing a freshly out of oven warm paper versus a peer-reviewed published paper, right? I'm pretty sure after this goes through peer review process, they'll ask them add all these evaluations.
But I have a question for you guys. Do you think that adding RAG to the training process is as novel as they describe?
I guess so. Have you seen other papers doing that?
I haven't seen any other papers, but
maybe it's common in industry, like proprietary training. Maybe
it just doesn't seem like a massive leap to me in terms of incorporating these two techniques together. It would be great to hear what the authors think, though, because, like, for example, we know that I'm sure I can find a talk somewhere from one of the people at OpenAI talking about how they already do this, or they do this in some way.
Yeah. It's definitely not a revolutionary paper. I kind of see it as it's just like it's more application. It's an interesting application of or it solves a valuable problem, which is doing question answering over very domain specific data.
For sure.
Just like feels like a gold mine.
What I actually was after I read the paper, my thinking was like, I would love to see the extension where they just have a set of documents and they come up with a data set of question answers for those documents to train a model to answer like domain specific questions. So you don't have, because now all the data sets require question answers already created by some kind of human. But that's actually a huge limitation.
Yeah.
So, I'm pretty sure that, I mean, there's a lot of APIs out there for creating question answers.
Yeah.
But like, maybe I'm sure there's not like it's not the naive way probably doesn't work that well. So it'd just be great to see a paper where they're like, this is how you create a data set and a method such that when you're done, you have a model that can answer questions about what you care about.
Yeah, absolutely. I think people use like LLMs to generate question answers already, but yeah, it is a limitation for sure. Cool. So then, as I mentioned, so this is an example if you're interested on what like one of the training data samples looks like. So you have a question, you have the context. Here they just show the like Oracle documents, but like the idea is that you would also include some completely irrelevant documents in there. A question, and then the chain of thought answer. So the chain of thought answer, the way they get it is they use GPT-4 and they get it to generate like a reason, extracting a quote or the quotes that sort of give evidence for that reasoning, and then the answer at the end. Yeah, so I guess that's an example of them using an LLM to create a better training data set.
That's true. That's a good point.
And they do show that, yeah, here it can have quite a significant impact on the performance depending on the data set. I think one observation, like I think that's I found interesting thing here is that it's so data set specific. It just everything feels like it's so data set specific. Yeah, that's a great question. I'm guessing it's accuracy of like the correct answer, because they keep just saying like %. But they don't actually say what the metric is, which kind of sucks. But yeah, it all seems really data set specific. Cool. So then they ask a few more questions. So as I mentioned before, one of the things they do to create the training data set is that they purposefully create some samples where they don't include the Oracle document as context. And so they want to measure what, like, how can we tune this like hyperparameter P, which is what they show here at the top. So 0% means that you have question, completely irrelevant documents for every training point, and then the answer. And then 100% is that like every training sample includes the relevant document within it. And so they show that, like, again, it's dataset specific, but they show there might be some benefit in having training data or some samples which don't include the Oracle document. Though like looking at the axes, like you could argue it's not unless you're at 0 or 100%, it doesn't seem to be like a huge variation in performance, but some advantage. Also, I could not figure out for the life of me why. So that this whole paper is about domain-specific training models to answer questions about domain-specific data. Why is it that here they choose to use the common knowledge data sets and not PubMed and the Hugging Face or TensorFlow hub? Like, why? It's like, surely like domain-specific RAG, like focus on the domain-specific data sets. I don't know, it really confused me.
The only thing I could think of is the idea that the more experimental evidence you provide, the more likely your paper is to be accepted, even if it's not directly relevant to the problem. Because like the technique itself is being introduced to solve a specific problem, but it isn't specific to the problem itself. You could take any data set that you want to supervise, like you want to fine tune on, and do it for. So maybe something along those lines.
Right. Yeah. So like it doesn't matter. I mean, to peer reviewers, it doesn't matter so much that you use these data sets.
No, it does. I'm just saying that it would be like, it won't add a lot to your paper, but it adds something.
Yeah.
So they'll be like, oh, and it also worked in this other context, even though that's not the point of the paper.
Yeah.
That's my only guess.
Fair. So yeah, they look at this like hyperparameter, and then they also look at the like how the performance varies based on, so at test time, how the performance varies depending on how many distractor documents they put in training time. So the first two, the blue line and the orange line, the triangle and the stars, are like, the blue line is just provide the Oracle document in the context, or add one distracted document, or two distracted documents, or three distracted documents. So they show that there's benefit in introducing at least one, depending on the data set more, like distracted documents, presumably because then, like, again, the whole point of this being that you can teach the model to ignore irrelevant context. So if you're just teaching it in a context where there's just a perfect document always, then it doesn't perform as well in test time. Kind of makes sense. Sorry, was there anything? Explanation section 5.1 about what, sorry? Oh, about this. Yeah. Yeah, so they look at like, yeah, how many documents are good to include at training time in the samples. And that's most of the paper, really. So I guess just to recap, I think the best part about this, or the best things about this paper, are thinking about retrieval augmentation, not just at test time, but also at training time. And I suppose that makes sense. Like if you know you're building an application where you're going to be asking a model questions given context, it makes sense that you'd want to train it to perform that kind of task. So it's more robust to like ignoring irrelevant context and understanding like what's the appropriate context. And I think really that is the contribution, is like we created a new way of, well, like this is a new way to think about creating a fine-tuning data set that's not just question answer, because they don't change the method for fine-tuning. They haven't introduced a new method for fine-tuning, or a new way of doing retrieval augmented generation either. So it's conceptually very simple. It shows some promise across different data sets. So I'm kind of keen to try this on our. I would be keen to try this on our side if if creating the data set wasn't a pain. Have to create the data set first. Yeah. I think my main criticisms of the paper are like just that there's not much depth in the evaluation side. And again, I feel that even though it pitched itself as like being all about being domain specific, some of the evaluations just didn't consider them. Well, at least for the ablation studies and stuff. And lastly, you can't. I don't know if you can get away with it anymore to use GPT 3.5. Although I suppose they are using a 7 billion parameter, so you have to find some kind of fair comparison. But as more of a practitioner and less of a researcher, in my head, I'm like, cool, GPT 3.5 plus RAG, but actually what I care about is like with GPT-4 Turbo or Claude, is the performance, how good is that performance? And does it justify putting in effort to using this kind of method? Yep.
I was wondering, they ever mention which specific version of GPT 3.4, 3.5 this is? Whether this is the old 3.5, whether this is the preview version? Because there is quite a bit of like difference.
Yeah, I don't think they do. They do for GPT-4. They mention it's this model, but I haven't seen the same for GPT.
That's also a problem I've noticed in several other papers, which is like they mention GPT-4 or GPT 3.5, but never specifically which version. So they might be using the oldest version of GPT.
Yeah.
Yeah.
I hadn't thought about that. That's a really good point. It's a really good point. I would have loved also to. There's just so many. Yeah, I would have loved also to see them, to see how this changes from like a Llama 2 7B to like the next size up. I don't know. I forget what the next size up is, but just to show different
Either
model sizes.
13 or 70, actually. Not sure.
Yeah. Because we know that fine tuning and RAG, like, well, different model sizes seem to just perform. The results seem to differ quite a lot. So would have been interesting to see that. Any other thoughts from anyone? Did you enjoy the paper? Did you not? Curious to hear.
I thought it was a good paper. I know we've said some things that we think could be better, but I think all the bones are there. Like, it's a sturdy paper, and it does introduce an interesting idea. As I said, my thing is I want the follow-up work where they show us how to create the data set. That would be amazing. I think that would be really, if the technique is generalizable past the research paper, that would be a really impactful paper.
It's a good question, Vahan. I'd love to hear what everyone else thinks. Maybe you can type in the chat or feel free to comment.
Because these days there are so many new papers coming every other day. If you check LinkedIn or Twitter, there is always noise about a new paper. But then if you go into details, they are different in quality from peer-reviewed papers usually. But there is still a lot of benefit in reading these new papers, right? So I wanted to understand what's preferred. I guess it doesn't matter. We'll do mix.
So I just found out if you I don't know if you're aware of Llama Index, but Llama Index has like a RAFT dataset generator, which I think you give it a set of documents, it creates synthetic question answer pairs, and also like includes sort of relevant / and irrelevant documents. There's a Medium article here, so maybe your questions have been answered, Peter. You can try play around with Llama Index. Might have a look. Cool. Well, if there's no other questions or comments, thank you for coming to Paper Club.
Thanks for presenting, Gerard.
Thanks, Gerard.
Ryan, did you have a question?
Thank you.
Okay. Maybe not. All right. See you, everyone.